afternoon. We are happy to start the third session of the International Conference Mo.Na, Monuments in Nature Creative Coexistence. The third session is entitled The Interaction Between Cultural Heritage and Environment and the Effect of Climate Change on Monuments. This session has been prepared under the responsibility of the National Institute of Cultural Heritage. We are very pleased to be with you. I am Marsela Plyku Demaj.
And I'm Klodjana Gjata.
Both from the National Institute for Cultural Heritage in Albania. We are very pleased to introduce our keynote speaker of this session, Associate Professor Dr. Belisa Muka. She is Associate Professor in the Institute of Archaeology of Albania. She is Head of Department of Antiquities and member of the National Board of Archaeology. I'm pleased to give her the floor for holding presentation on the challenges of an integrated valorization of open-air archaeological sites. Professor Belisa, you have the floor.
Thank you very much. First of all, I would like to thank the organizers for their kind invitation to participate as a keynote speaker. I also would like to apologize for being virtually present this time due to travel restrictions. Well, my presentation will address some of the issues that face today open-air archaeological sites, focusing particularly in some case studies from Albania. It is essential to reconsider a multidisciplinary and integrated approach that is suitable both for scientific purposes, touristic and economic development, and for a full appreciation of the heritage. Now, we all agree that archaeological activities are one of the main threats to archaeological sites. As an archaeologist, very sensitive to the importance of conservative interventions, I'll draw the attention to some of the challenges that face today open-air archaeological sites. There is, on one hand, the necessity to have ongoing scientific researches and to provide adequate conservation and restoration. On the other, the valorization and cultural and touristic enhancement alongside the obligations to integrate local communities in order to make the cultural heritage not only visible, but above all, accessible and profitable.
Sorry, Professor.
The equilibrium is not always easy.
Presentation, sorry. Can you also visualize the presentation slides to move?
Yes, they will start.
Okay.
They will. Okay.
Thank you.
So I'll soon pass to the main thing. I'll consider, given the restricted time on our disposal, some case studies that reflect the necessity of this equilibrium between the ongoing archaeological researches and the conservative interventions for a better comprehension of the structures. Now, let me take you to Apollonia. I'm not entering the historical problems related to the site, as it is all known, but we'll focus on some specific cases. A very interesting context in Apollonia is the theater, located in the center of the town, providing connection between the upper and the lower city. Now, it is known to be not only the biggest monument so far identified in Apollonia, but also one of the biggest theaters of the Mediterranean area and the biggest structure of this kind constructed in the polis of the Adriatic coast. Now, the monument of the main phase, let's say, is dated in the middle of the 3rd century and was able, before BC, and was able to accommodate around 1100 to 1300 spectators. Now, something that archaeological excavations has brought to light during the Roman period, which is by the end of the 1st century AD, beginning of the 2nd century AD, the theater was modified into a Roman arena, suggesting its use for different gladiatorial games. suitable for different gladiatorial games. Now, what happens is that the front seats were removed for the construction of a parapet that would, of course, aim to protect the spectators. So the certain Hellenistic parts of the Hellenistic theatre no longer existed in the Roman period. Therefore, the new monument was no longer in possession to accommodate artistic events. Therefore, the construction of the Odeon in the Hellenistic Agora should be considered in relation to the transformation of the theatre. Any interventions in terms of the restoration of the structure should reflect the dynamic of the transformations that the monument went through its history. Protection techniques are based mainly on two types of approaches. Temporary structures, that they are, of course, we have to accept, they are generally, they start as temporary, but then they are generally, they become permanent ones, and stable structures designed for musealization of the archaeological area. My second case is in Apollon, in Phoenicia, and of course it's known the importance of the site as the capital of the koinon of Canaan. Now, let's take into consideration a small monument, a so-called thesauros, a small one-room construction from the Hellenistic period, excavated in 1926 by Ugolini, and defined by himself as a thesaurus on the basis of formal assonances with this type of architectural typology. Now, the interpretation of this construction as a small Doric temple in Antis essentially is based on the hypothesis of a symmetrical extension towards the south of the east wall, similar to the one to the west, so as to form a pronaos in front of the cella. Now, since the very beginning in Phoenicia up to recently, almost 10 years ago, in all the publications, we would see a small temple in Antis. Now, the ongoing archaeological researches within the framework of an Albanian-Italian collaboration have changed completely the interpretation of this context as a sacred place. Now, without going into the details, instead of a small Doric temple, we have the northern part of a stoa with a southern paraskenion, a single corridor, a structure about 30 meters long with 4 meters wide, similar to models of this kind of public buildings that have been excavated in neighboring centers like Elea or Gitana. Another case, of course, again to the necessity that addresses to the necessity of ongoing archaeological researches, comes from Orikos. Excavated in 1958, for decades, this monument was believed to be one of the rare theatres documented in the area. Now, once the site was object of researches in the framework of a collaboration between Albanian and Swiss archaeologists, it was understood that the so-called theatre was in fact a monumental fountain, occupying almost the entire agora of the city. With most of the architectural elements in situ, we can have an adequate restoration of this important monument. And of course, my last case study is from Butrint, which is the main, let's say, site that has been taken into consideration during this important project. We know the history of the city is quite long and complicated, but we'll focus in this case on the Roman period. Now, we know that the colony was founded in 44 BC through the agency of Julius Caesar, and the colonies consisted of Roman citizens and large numbers of freedmen, many of whom were clients to powerful senators and equestrians in Rome. Now, the Forum, which is the focus of my case study, is an important monument and an imprint of Butrin's importance during the Roman period. In fact, the construction of this most emblematic Roman public ensemble consists in demolishing the ancient agora and remodeling many of the existing. Formation of Butrin is documented considerably by the archaeology. The construction of the new forum, a tripartite structure, was surrounded by new buildings. Of course, of particular interest are the pavements, the fine pavements identifiable in all the buildings of the urban center, with a wide radiance that must have distinguished Butrin compared to others. This area has gone through several transformations over the centuries. They are all detectable through the archaeological research. Now, this case brings me to another important point that interacts with the first. These discoveries concern, above all, of course, the history and the dynamic of their transformation, of each site's transformation during the course of their history. But at the same time, they shed light to the story of the people and the institutions that have contributed to these discoveries. Most of the archaeological sites that have been part of my discussion, but also excavated in Albania, with some eclipses, have been excavated for over a century. It is a history there that needs to be told and explained, also in terms of perspective and methodology changes that mankind has gone through. Now, to ensure an integrated approach to valorization, we must consider the development of the digital technologies and other alternative forms that need to be deployed in order to make the structures visible, even when they are not. Here we are in Apollonia with another important monument, which is the porticus of the upper agora. Anything you can see is what you get. What you get is what you see, which is very difficult to materialize in terms of the importance of the structure. And therefore, any kind of, let's say, interventions that would make the structures visible, starting from the Basilica of Siponto, most of them works by Eduardo Tresoldi, or the maquettes that now have been produced. You have here the example of Apollonia with the support of the Ministry of Culture, of course, supported also by our project. These are alternatives that needs to be considered in order to make visible monuments even when they are not visible. Also, what is another point that needs to be taken into consideration are new touristic itineraries, consistent both with archaeological and environmental characteristics that needs to be designed. Now, archaeological sites, if properly organized, are in fact able to promote and enhance their context, even in areas that are less developed, improving their ability to attract visitors and thus creating an economic driving force from which the resident population can also benefit. The conservation and enhancement of archaeological sites around an area that we know better, which is the coastal Caonia, represents an important asset in terms of the richness and diffusion of sites. The creation of alternative itineraries that will embrace not only a site, but a chain of smaller archaeological centers in the territory will better enhance the cultural heritage. If the archaeological research, restoration, and valorization of the cultural heritage does not provide benefits for the communities, our job has not been done properly. Thank you very much indeed.
Thank you, Professor Belisa, for your interesting presentation, as always. In fact, open-air archaeological sites are always a challenge to manage and to be valorized. Now I would like to give the floor to my colleague Marsela with the presentation of a case of a post-disaster risk assessment method for cultural heritage monuments and sites implemented in the aftermath of 2019 earthquake in Albania. Titled A Rapid Damage Assessment in Earthquake Damaged Heritage Buildings, a case study of November 26th earthquake in Albania. The floor is yours.
Hello, thank you. In fact, this is a presentation prepared jointly by Klodjana, my colleague, and myself. It shows a real case when the disaster, such an earthquake, was managed by groups of people, of dedicated people, of volunteers, and of institutions. We are going to see through the presentation the way that we acted during this earthquake. So we are speaking of disaster loss, which is on the rise with grave consequences for the survival, dignity, and livelihood of individuals. And disasters are increasingly of global concern, as their impact and actions in one region can have impact on other regions as well. So, speaking of 2019, which was the year when the earthquake in Albania happened, in the global level, the climate breakdown played a key role for at least 15 events in 2019 that costed more than 1 billion in damage. It included extreme weather like floods, storms, droughts, wildfires, and earthquake, which in this year impacted the inhabited continent. Here is an overview of the disasters happened during the 2019, highlighting the Albania earthquake, which was considered as a significant earthquake worldwide in terms of damage. So the great tragedy of climate change is that it is the poorest and the most vulnerable who suffer the most, despite them doing the least to cause it. We can see the costs of damage caused by extreme weather events in the continents, different continents. Now we are trying for you to consider how it may happen. You are totally unprepared, and it starts to shake. It happened in 26 November in 3:54 a.m. while everybody is asleep, and it lasted for at least 50 seconds, which by experience was like it wasn't ending. It was a 6.4 magnitude earthquake, and it resulted in the loss of about 51 human lives and 3,000 injured. As I said, it was the second earthquake to strike the region in the space of 3 months, from September to November, and the strongest earthquake in Albania for more than 40 years. When we talk of disaster, we speak of human lives and of homes. But in our afterwards, also in our responsibility as the National Institute for Cultural Heritage comes the heritage sites. We are in 3 a.m. in the morning, and the photos received immediately from our staff in site came during this time immediately. So the Castle of Durrës and the Castle of Preza heavily were damaged from the shaking of the earth. Immediately, as procedure, the Ministry of Culture, through its Civil Emergency Planning Commission, organized and coordinated the inspection of situation in cultural heritage buildings and sites in the territory of Albania, but taking into priority the first category monuments in the most affected areas, which were the municipalities of Durrës, Kruja, and Tirana. National Institute for Cultural Heritage is the main institute for cultural heritage in Albania, and it works in the regions through 6 regional directorates and offices of administration for archaeological parks. We're talking about hazard event, and considering the cycle of preparedness and response, we immediately started with the damage assessment. So the Civil Emergency Planning Commission requested the institutions to provide detailed information with regard to the situation of cultural heritage, monuments and sites. The technical teams from the National Institute and from the regional directorates were formed and set up by specialized institutions. And the technical teams were requested to carry out a rapid visual assessment. Now, the methodology used for creating a dedicated form for this kind of disasters for the rapid visual assessment was prepared in close communication with the advisory bodies of UNESCO, ICROM and ICOMOS. We need to consider that the National List of Cultural Heritage Monuments and Sites includes about 2,224 monuments, out of which 1,284 first category and the rest second category. A total number of 260 monuments and sites have been inspected in the course of 2 months in the whole territory. This presentation aims to present this methodology and the rapid assessment form created for this purpose from the cultural heritage institutions. In this case, it actually resulted to be a successful method, since immediately the rapid assessment began and we had the clear panorama of all the damages and the situation in sight. I must say, before the sector of tourism and before the sector of housing. One weak point that I need to mention is that although the technical teams were immediately on site, we were not as organized with the operating civil emergency agencies to form a joint and multidisciplinary teams, but we had dedicated teams for heritage, and the emergency department operated for the housing mostly. So the rapid assessment forms has four main parts. It is the details for inspection number and the inspector, the details for the monument description, for the code, designation, category, address, and the characteristics that the monument has. It is an evaluation of the damage, which resulted in 3 colors, like green, yellow, and red, and the necessary measures that the team on site proposes to be taken in case there are emergency measures to be taken. I must say that the part of the teams were structural engineers and architects specialized in cultural heritage restoration. So from the results, we immediately had on GIS the panorama of the points of monuments based on colors. So we had 25 at risk, 30 temporarily used, and 155 not at risk. But the most risked sites, like the Castle of Durrës, one of the towers, like Tower C, were heavily damaged from this earthquake. And I can show in a quick view the pictures of the monuments that were mostly damaged from the shaking. We are in the fortification of Preza, where walls and the clock tower as well as fortification towers were damaged. This is the clock tower again in the castle of Kruja. Mainly you can see that high structures were impacted the most from the damage. Also, in the castle of Kruja, due to the earthquake, the substructure of the castle, which is rocky, is reported to be highly affected and to display large cracks, like shown in the picture, which further affect the stability of the castle and the clock tower. The Teke of Dolma, which is also, its interior is decorated with high-quality frescoes, was damaged. You can see also the damaged frescoes in the inside. And several other monuments, like the Faculty of Geology and Mining, were among the most risked monuments. So immediately the measures taken were the security perimeters, the shoring and propping measures, and the controlled dismantling in some of the cases, like in the castle topping of the walls that risk to fall and risk the inhabitants. 3D drone survey in the castles have been conducted, and the Department of Art works in the National Institute went on site for gathering and cataloging the fallen fresco parts in the Teke. We asked in cases of substructure stabilization the help of the Albanian Geological Services and the Institute of Construction for undertaking a detailed analysis for, in terms of structural stability. The immediate process that followed the earthquake was the preparation of the post-disaster needs assessment document. It was a document prepared by the whole sectors of the country, and it was prepared under the guidance and of World Bank and the UN agencies like UNESCO, UNDP, etc. For the cultural heritage, as we see, we speak in million euros. It is 5.31 damage, and in total we have 5.75 cost of damages and losses. While the recovery needs for the cultural heritage sector were estimated to be 7.41 million euros. We were in, as state party, we were in the International Donors Conference after the earthquake and presented the PDNA, which was very successful since from the Brussels Donors Conference, Albania, for the recovery, enabled to have help out of 1.15 billion euros. That was the basis for starting the EU for Culture program. This was a signed memorandum between the European delegation in Albania and the Prime Ministry and Cultural Heritage sector and infrastructure sector for the starting this program for the rehabilitation of cultural heritage sites. Now we are in process when the most risked monuments from the earthquake have started to be restored and stabilized, their structure stabilized, but not only this process, also this process has a Build Back Better aspect. So all the projects are including also the awareness programs for the young people and the inclusion of specialized staff for preserving most of these monuments, so that the restoration ends up not only as it was, but with a more awareness rise in community and with a better environment. Thank you very much.
Thank you, Marsela. This is how the climate change can attack also cultural heritage. Now, I'm pleased to give the floor to a young, talented archaeologist, our colleague Renald in National Cultural Heritage Institution. His presentation is titled Risk and Benefits of Cultural Heritage from Construction Projects, so development projects, discovering and rescuing the past of Albania.
Okay,
the floor is yours.
Thank you, and thank you all for having me today. I will immediately start without losing time. So, a little introduction in the beginning. In a developing country like Albania, infrastructure works and construction projects are expected to be in relatively large numbers. Because these kinds of works have a direct impact on the underground, there is always a possibility for the presence of the cultural heritage component. Until 2009, the term rescue and preventive archaeology were little known and, above all, not much applied in Albania. This has led to the possible endangerment of cultural heritage that has been affected by construction works all around the country. A turnover was made with the creation of the Archaeological Service Agency, in short, ASA, that had to exercise activity in the area of the excavations and studies of cultural heritage that is affected by construction works of any kind or plans of territorial regulation in advance. This brought the creation of a new market that would include a number of professionals in the cultural heritage field of work. The archaeological excavations that till now have been directed from the academic institutions would also be led by ASA, licensed companies and individuals as free professionals. So, the safeguarding of national archaeological heritage is not going to fall only within the expected role of the state. As there would be a good momentum of construction projects, the controlled activity by ASA and the licensed individuals would bring an increasing number of discovered archaeological components. We come here to one of the main points of this paper, the benefits of cultural heritage. First one, a benefit is a funding of the archaeological processes of work from the project's developers. Funding is an issue for the archaeological scientific researches, but in the case of the construction project, the investors are under obligation to fund the archaeological work made by state, institutions, or private individuals or companies. Second, new archaeological finds and sites. 380 meter squares of a Roman necropolis were excavated in 2012 with more than 100 graves. Just next to the necropolis, a 1957 excavation was made, results of which were only 9 excavated graves. In a case of a survey made due to a hydropower plant construction, 20 unknown tumuli were discovered and documented. More recently, the Trans-Adriatic Pipeline project has brought into sunlight 30 new sites. During the project life, a range of areas of cultural interest were identified from the prehistoric, classical, late antiquity, medieval, and Ottoman period. Third, large-scale excavations. The 215 kilometers long pipeline has enabled the execution of large excavation. Here we're talking for Trans-Adriatic Pipeline again, like the case of the 4,000 meter square cemetery with hundreds of graves and archaeological traces excavated and documented that you can see in the picture in the left, dated in the 10th, 9th centuries BC to the late Roman 4th, 6th centuries AD, and with a reuse in the Middle Ages, 12th, 15th century AD. Another case, in the two pictures in the right, in the ongoing infrastructure project in the ancient city of Apollonia, due to which till now, a surface of 2,500 meter squares of a Roman necropolis is excavated. Filling the gap. New finds also bring some new data, filling the vast part of the known historical chronological line. In the UNESCO site of Berat, a Paleo-Christian mosaic was discovered as the floor of the 4th, 5th century basilica. No excavation project has taken place in decades here, and we didn't know much for this period till this important find. Also, the construction projects brought into attention the need for a management plan for cultural heritage during the project's development, zoning and drafting of archaeological sites, knowing the importance of preventive archaeology instead of that of salvage archaeology, relocation and the rescue of the archaeological finds and structures. Although many benefits may come from the construction works, risks are inevitable. In general speaking, the biggest one is the loss of the archaeological features and data. This might be caused by following risk, also called reasons. First, clientelism and corruption. Because the construction projects are designed by companies to make money, the archaeological heritage is a nuisance for them. In fact, the reason why we have this development of preventive and rescue archaeology is because of the state legislation. It is clear that the interest of the private companies is to raise their earnings. The presence of private archaeologists bears within the purely logic of economic fluctuation. Also, some construction projects have been completed before archaeological work has been done. This may also come from the negligence of these professionals, which brings us to doubt their reliability. It's seen in the reports of some licensed individuals. Second, the confrontation. Especially in the urban areas, the construction projects are the biggest risk for archaeology. Here, we automatically have a confrontation between the cultural interest and private profit or urban development. Extreme cases come from Durrës, the ancient Epidam Dyrrachium, where a 3,000 square Roman urban unit is now under a 6-floor building. The pictures show in the left the excavation process, while in the right the basement of the building with archaeological structures. In another case from the same city, the Byzantine structures discovered during the foundations digging work are now part of a wine bar restaurant on the first floor. Just next to these structures, due to a public project, some other structures were found, excavated and then buried under a concrete mass. Picture is left is in 2017, taken from Google Map, just before the covering of the structure. While in the right is a picture where the structures are fully covered. Number 3, the truncated publications. Every year since its creation, ASA has published an annual report on its activity, while the reports form private parts on their work stay in the preliminary report phase. ASA has published till now only the study of the 380 meter squares Roman necropolis that I mentioned above in slide number 4. This situation may result in loss of archaeological data. To conclude, the construction works brought new data, a new market, and new situations for cultural heritage. Preventive archaeology has been implemented due to the legislation changes in 2008 and lately in 2018, which resulted in a better control of construction activities as for cultural heritage issues. Although with some benefits, the construction projects bear several risks, which in some cases have endangered and damaged archaeological components discovered during the project's executions. The developers of the construction projects do not want to have the best archaeological services, but demand that as soon as possible the release of their construction space. Knowing this, archaeology professionals should try to do their best to help protect our common cultural heritage, despite the fact that for this work they are paid by the developers. However, at this point, they know very well that builders are required by law to do so, and this is in favor of cultural heritage and professionalism. If there is going to be a competition in archaeology for this occasion, it should be not in the price, but in the quality of the service, not for the benefit of the customers, but for the cultural heritage. I thank you for your attention.
Thank you, Renald.
Interesting overview of both the benefits or risks that development project may have on archaeological finds. Now the interesting thing is how to find a balance between the two in favor of the cultural heritage. Now I'm very pleased to welcome here Professor Constantinos Cartalis from the National and Capodician University of Athens in order to present his presentation on a very interesting interdisciplinary project, CLIMASCAPE, an expert system for the adaptation of cultural heritage sites to climate risks associated to the natural landscapes. Please, Professor, the floor is yours.
Okay, thank you very much for the opportunity to present this study. It's a research project undergoing at the University of Athens together with the University of Thessaly and the National Foundation for Research. And the aim of the project is to prepare adaptation plans through a multi-criteria system in order to adapt archaeological sites with respect to the impacts of climate change. So the main issue with respect to this is that we need to adopt a precautionary principle approach to minimize the risk to cultural heritage, which are associated with climate change. The project is called CLIMASCAPE, and you can see in the map that is been depicted in the transparency the areas that we monitor, and we do research with respect to the impacts of climate change. The objective of the project is to develop a multi-criteria system, as I said before, for the adaptation of the archaeological sites to impacts of climate change which relate to the landscape, so practically to the natural environment which is in the vicinity of the archaeological sites. And these climate risks are the extreme weather events and floods, forest fires, drought and erosion, heat waves and sea level rise. Eight archaeological sites in the country have been selected. They all are included in the World List of UNESCO, and the aim is to put together all the different risks and monitor the impact and the adaptation measures to be promoted. So this is the first page of the website, and you can see at the top the site, the address if you wish to go through the project. One of the areas is the ancient Olympia. I will exemplify the presentation with respect to this specific area, showing how we approach and how we try to develop the adaptation plan. So what is the basis of the project? The basis of the project is to define vulnerability to climate change. And this is a fundamental information both for the present and for the future climatic conditions, and has to be taken and has to take on board the exposure to climate change. For instance, if we talk about a coastal community, which is 500 meters from the sea, this community will be exposed to cyclones, to extreme weather events, rising sea levels, and intrusion of salt water in the aquifers. This is supposed to be the exposure. Then we have to take into consideration sensitivity. Sensitivity depends on the characteristics of the area. For instance, in the example of the coastal community, if there are no wind-resistant trees in the community space, then the sensitivity is higher. Or if the area is a little bit below the sea level, like some countries in the region, then the sensitivity is even higher. And the third parameter is the adaptive capacity. That is, what kind of works can you promote in order to minimize or to reduce the risk imposed by climate change. So these have to be put together, and this is a transparency which practically graphically depicts what we are supposed to do, what we are doing. So you have the adaptive capacity from the one side and exposure and sensitivity from the other side. And vulnerability depends on the balance in between. So at the top, where we have more adaptive capacity as compared to sensitivity and exposure, then the vulnerability is lower. At the bottom of the transparency, we can see that the exposure and sensitivity have a higher weight. In this sense, the adaptive capacity, the vulnerability is higher. So we are taking into consideration the areas and try to put together all the different risks, but we also look into the future because it's important to know what is going to be the change in climate with respect to the specific areas that we monitor. So we have to go to the future, but the future is difficult because we have to model and we have to choose the right scale for the adaptation plan. In the past, there have been applications with global and regional models, but you can see that the areas are too wide, at the best 50 to 50 kilometers. This is not an information which is very useful for assessing climate risk. So we are now using downscale methodologies, and we are having the results at 12.5 to 12.5 kilometers, which is a much better grid size in order to assess the impacts. And you can see the difference. In the left part of the image, you can see the climate risk, the increase of temperature for Greece. with a regional model at 50 to 50 kilometers. And to the right part of the image, you can see the climate simulation when we apply a downscaling climatic modeling technique, and we have the information at 12 to 12 kilometers grid size. So you can see the improvement with respect to the spatial resolution and the capacity to get more information and bring this information to the adaptation plan for the archaeological site. And in the right part of the image, with the red dots, you can see different areas where we have estimating the higher increase of temperature. So we have to define the climate risk and the related parameters. So what is the climate risk? It's drought. Drought reflects air temperature, the maximum number of continuous dry days, a couple of indices which are important because they put together different parameters including moisture. Then we have forest fire. It depends on air temperature, on the wind speed, on the number of dry days, on relative humidity, the humidity of the ground, and again this is an estimate for the future climatic conditions on the basis of the climate modeling. With respect to the methodology, this is the plan. We start with the ground for adaptation, that is to assess the areas with respect to their specific characteristics as far as the landscape is concerned, to assess the risk and the vulnerability to climate change, identify adaptation options, assess the options, which is important because you have to know what is the capacity of the option to ameliorate the problem, implement, and monitor the evaluation. So let me go through a specific case study which is about ancient Olympia. Ancient Olympia is one of the areas which is facing landscape-induced risk. It's not the archaeological site itself which is in danger. It is the natural environment in the vicinity which is imposed in flood risks and in forest fire risks. And the area is surrounded by extensive forestry. This is, of course, very nice for the landscape, but it induces endangerment for the area once we take into consideration the risks with respect to the dry days and the minimization of moisture of the ground. So we have to take into consideration the ground for adaptation, that is to assess the current and the future climate. So this is the difference for July going to the future as compared to the present. And you can see with the arrow the area of ancient Olympia. So we have an estimate with that the temperature by 2046 to 2067, that is in about the next climatic period, is going to be roughly 3 degrees centigrade higher than today. This is not the only information that you have to take into consideration. You have to use precipitation. So you can see the difference in precipitation, again, for the different parts of the country where we have defined the archaeological sites. There's always a decrease in precipitation, and this is not beneficial because it increases the chance for a forest fire. And then we have the summer wind. Again, this is increased, and this is, again, something that has been taken on board because it increases the severity of the fire once this is ignited. Another important information is the moisture deficit, that is precipitation minus evaporation. So if this becomes a deficit, that means that the ground becomes drier, the burning fuel is more susceptible to ignition, and once there is a fire, the burning fuel is much more, and it gives more power to the fire. And this, again, is the impact with respect to climate change according to the climate model. I know that there's a criticism about climate modeling, and there's a question, how do we validate something that is happening in the future with respect to our approach? We do that by applying the same climate model to the past. So we choose a period when we know what the climate conditions were, for instance, from 1980 to 2000, or from 1970 to 2000, and if the climate model is successful to replicate the climate of the past, which we know, then it is credible to be used for the future. And this is how we do the validation. And this is a very solid validation because in this way you have a good confidence that your estimates will be verified in the future if, of course, things get better with respect to the efforts of the international community. So we have developed a major repository of data and information about the main climate risks for the area, which is forest fire, heat exposure, and floods. So, again, the same mistake. So the first one is to map the nearby rivers. Ancient Olympia is the place where the red dot is, and you can see that there is a river going by, which in the past has demonstrated some excessive level because of extreme weather events, extreme rain as a matter of fact. So we have the mapping of the nearby rivers. And then we have the flood risk mapping. And you can see that the river and the coastal zone is far away. We don't have any kind of risk for ancient Olympia. But with respect to the river, an area which is close to the archaeological site is being depicted with red, which means a high risk for flooding. And then the past fires mapping. This is important because we have to see what happened in the past and how much burning fuel is in the area and how the fires of the past did propagate once they ignited. And this is a very important information to know how a forest fire will move in the future, if it finally happens. Then the forest density, extremely important for the intensity of a fire, of a forest fire. Again, in every single slide, you can see with the red dot where the archaeological site of ancient Olympia is. For instance, in this specific case, this is the place. And there's the forest density. The forest type, again, these are different forest types, and this helps us calculate the forest fires index danger for the area through a number of mathematical formulas. What is important also to know is the land cover types. And this is based on satellite images. Again, ancient Olympia is somewhere here. And you can see the different types, mostly agricultural, forest areas, areas where there is mixed forest, and so on and so forth. Why this is important? Because by having this information, you can assess the risk once again. And then the impact area. So we have two different impact areas. The first one is with respect to the forest fire, and the second one is with respect to the flood. So these are the areas where we have to monitor and develop the adaptation plans. And also take into consideration what I said before, that the climatic conditions are changing. So we have also estimated through another project, an indirect project this time, the forest fire index for the future with respect to the different areas. Ancient Olympia is here, so we can see what the index, the increase of the index is. This is an important information for Civil Protection Authority, so as to modify their plans for the protection of the area. But this is not enough. We have also to assess the impact to the museums as far as the increased energy needs for cooling are concerned, and this relates to temperature. So a better look to the temperature has to be correlated with what we call the cooling degree days. This is a specific parameter which says that whenever the temperature is higher of a specific number, you have to use air conditioning. So you have to use more energy for cooling. So the more cooling degree days due to the climatic change, the more need for energy for the operation of the museum, for the exhibits, for the workers, and for the visitors. So we have calculated all the cooling degree days, and you can see the increase with respect to the different areas where we have this project, from Delos to Samos, and ancient Olympia, Philippi at Kavala, and so on and so forth. And then what about the visitors and the workers? Ancient Olympia is an open archaeological site, so people may be exposed to higher temperatures. We can see that even today. More heat waves, and the estimate is to have more and more intense heat waves and of higher duration. So in this case, we have to follow the number of heat wave days for the future as compared to the previous climatic period. And again, this is the estimate. So this is an important information. What are you supposed to do with the archaeological site once you have more open air pressure through the thermal pressure? And what is going to be the plan to adapt the area with respect to this? So putting all these things together, we have defined a multi-criteria system which every single intervention tries to show how the impact of climate change is being minimized or reduced. And this could be an adaptation plan for ancient Olympia. We haven't concluded yet, but this is a draft one. To work out technical infrastructure to secure the archaeological site from the increased rates of flooding. The second one is to have more frequent below-ground drainage maintenance. So we need technical works. It's not just to accommodate the visitors. We have to do some technical works for the area. To enrich the aquifer, to increase soil humidity, very important. To consider the use of appropriate plantings that hold water and provide shade. To remove the amount of burning fuel in the forested area. To expand the forest zoning, to keep the forest fires in distance. To prepare a locally tuned fire dispersion model in support of the private brigade efforts. To assess the need for an advanced fire protection system. To apply conservation measures to avoid the cracking of hard materials due to thermal stress, to promote shading for the workers and the visitors, and examine the schedule for the operation of the archaeological sites in the event of heat waves, for instance, moving the schedule towards the afternoon instead of the morning, and to energy retrofit the museum to cope with the climate prediction that we need more cooling degree days. So this is pretty much the project. It tries to look to the future in a precautionary way so as to promote a number of adaptation measures for the area of Ancient Libya and 7 other archaeological sites in the country which belong to UNESCO World Heritage List, and tries to bring a new discussion about the link of climate change to natural and cultural heritage. So thank you very much for your attention. If you need more information, this is my email. I will give, of course, my presentation to the organizers for the minutes or for the proceedings, not for the minutes, for the proceedings. So thank you very much.
Thank you very much, Professor.
Thank
For the very interesting presentation. Indeed, it again showed how interdisciplinary approach in several fields like geospatial, environmental, climatic, and social can contribute to the protection of archaeological sites through the threefold prediction, detection, and management. I am very interested to see how this can be replicated also to the other archaeological sites, with the view of having also adaptation plans besides the conservation plans for these sites. Thank you very much.
Thank you, Professor. Now I'm pleased to give the floor to a presentation entitled "The Role of the Relative Sea Level Rise in Geocultural Heritage." Professor Niki Evelpidou, who is a professor of geomorphology and geoinformatics in the National and Kapodistrian University of Athens, could not attend today, but we have a pre-recorded presentation. We invite you all to see it together.
Good evening, everybody. Before I start my talk about the role of relative sea level rise in geocultural heritage, I would like to thank the organizers for their kind invitation to join this interesting conference. Coasts are among the most dynamic parts of the Earth's surface. The geomorphology and sedimentology of the coastlines today is a result of the sea level changes, mainly during the Holocene. Sea level changes and tectonic movements have often resulted in the abandonment of ancient harbors such as Lechion or Phalasarna, in the submersion of coastal archaeological sites such as the Roman city of Vaia, or even the adjustment of coastal population to relative sea level change. As a result, the coastal and underwater environment hosts geomorphological and archaeological features testifying older shorelines and a different paleogeography. Such areas are often sites of significant geocultural heritage with unique characteristics. Let's see here how the increase in temperature affected the sea level. In fact, sea level changes in the Mediterranean are affected by a static factor, and in these changes, vertical tectonic movements of land are added. The sea level fall observed during the last glacial zenith reached 120 meters below the present. Between 18,000 years and 7,000 years before present, the sea level started rising at a rapid rate of the order of 1 meter per century for many millennia as the ice sheets collapsed. The maximum rate is noted during the ice sheets retreat, reaching several meters per century. However, the rate of sea level rise is not representative of the present, as the distribution of ice sheets in the 21st century is quite different. Between 6,000 years and 2,000 years, the sea level rose at a slow rate. In fact, about 2.5 meters in 4,000 years, and even slower in the last 2,000 years of that period, meaning the 18th century. For the last 2,000 years, models are developed for the Antarctic ice sheet that show a continuous but slow dynamic response to climate change since the last glacial maximum, contributing by 0.2 millimeters per year in the global mean sea level. This rate is slightly larger, but in agreement with the indications of a very low rate of paleo data. Let's have a look how this part of Aegean looked like during Quaternary and how the geography was changing during Holocene sea level rise. Here you may see the area of Cyclades 18,000 years ago when the sea level was 120 meters lower than today. It is clear that the eastern Cyclades were united into a larger island. And here the area at 14,000 years ago, and here at 13,000 years ago, when sea level was 60 meters lower than today. And here how it looked like almost 12,000 years ago, when sea level was about 40 meters lower than today. And here as the area looked like nowadays. So we can understand that the prehistoric map that inhabited the Aegean region after 18,000 years BP becomes a witness of cosmogenic changes, especially with regard to the change of the coastal landscape, since year after year they were flooded. You may see in this photo Magazakia in Parikia, Paros Island, it's in central Cyclades, submerged. And below this photo, you may see a schema with the submerged events we have mapped because of the seismic events that took place in the area. And at the right part of this schema, you may see the dates we believe its submergence took place. We may understand how all this affected the humans at that time, as the sea transgression was fast and they could see the sea level flooding their space. An example is how the inhabitants of Naxos dealt with the rise of sea level caused by an earthquake about 350 BC at Gorota. The construction of the floor of new rooms were built 10 centimeters higher than the earlier floors. The pebbles placed under the floor of rooms were probably used as a means of drainage, a way of preventing the moisture to penetrate the room. Let's move now to Italy and to Phlegraean fields and the town of Puzzoli. Already from the 19th century, the importance of the archaeological remains in Puzzoli was recognized for the connection of relative sea level changes, tectonics, and volcanic activity. The columns in the Roman market were used as paleotidal gauges by pioneer geologists like Lear. The columns were constructed above the ground. They were submerged below the sea level and were after uplifted again. In the middle of the column, some dark zones are visible, which were created by mollusks that made holes. Lithophaga in their home holes were used for dating. Now let's move to the eastern part of Aegean. The southeastern coast of Samos are characterized by a complex tectonic regime. Archaeological data from the area suggest a subsidence regime. And corings performed in 2 lagoons in the area have shown that the southeastern part of Samos is indeed under sea level rise trend at an average rate of 0.8 millimeters per year since about 6,000 years before present. At the same time, there are geomorphological indicators making clear that we have in this area both subsidence and uplift events, which makes the interpretation of sea level fluctuations very difficult. And as I mentioned, the tectonic regime is complex, and the findings suggest vertical displacements related with the major faults of the area, which are cancelled out by other faults dipping in the opposite direction. Maybe you are aware of the earthquake that took place on 30th of October 2020 with a magnitude of 7 at this area. On Samos, 2 teenagers were killed while returning from school to their home, and more than 1,000 buildings were recorded as unsuitable for use. The temporal was far more devastating for Turkey. So my team, just after the earthquake, re-examined various sea level indicators by comparing our measurements taken in 2015 with the new measurement just after this earthquake in 2020. And based on our findings, we concluded that the island in this specific earthquake has been cosmically uplifted, but with a different magnitude. As you may notice from the map at the up left corner of this slide, during the earthquake, the western part has been uplifted by 35 centimeters, and this movement is fading out to the east. But at the right lower part of this slide, you may see submerged sea level indicators from previous co-seismic events, which nowadays are uplifted because of the earthquake of 2020, but still submerged. The Asian habitation in the Mediterranean has left plenty of information along its coast, and it is clear that some archaeological constructions contain interesting information regarding the magnitude of the relative sea level changes since antiquity. Roman fish tanks are particularly significant archaeological indicators. A detailed survey of 8 fish tanks along the Tyrrhenian coast of Italy have been constructed between the 1st century BC and the 2nd century AD, included underwater measurements of geomorphological features and archaeological remains related to past sea level. Interesting information were gained about sea level changes during the Roman period, and specifically we found that local sea level during the Roman period did not exist 58 centimeters below the present sea level. Moving again at the Aegean Sea and the central part of Aegean, and in fact in Naxos, this area is situated in western Naxos, southern than the nowadays port. And it is a coastal lagoon, as you may see from this photo, with nice beach full of sand dunes, which is vulnerable to sea level rise and to coastal erosion. This vulnerable area is protected by submerged beach rocks. Beach rocks is the formation that you can see in this video, and basically corresponds to a fossilized beach. What we can see here is the same area that we saw in the video before, where the beach rocks are noted together with the date of their development. We therefore can have a clear idea of the rate that the land retreated due to the sea level rise. In this area, we have done many shallow drillings, and we have studied the sediment, the stratigraphy, the fauna, and we have dated our findings, and we could reconstruct the paleogeographical evolution of this area. Our findings show that there was an ancient harbor which was active from at least 6,000 years ago until 232 years before present. This harbor probably used to serve the ancient area at that time. We can also see the reef, which is owed to the submerged beach rocks. I mean the fossilized beaches we were talking before, and the dating of these fossilized beaches gives 1,500 years ago and 4,500 years ago for the deepest beach rocks. And over the last millennium, the harbor turned into a shallow lake gradually, and the sediments brought by the nearby river that starts from upstream and flows into the lagoon make it a shallow lake as it is today. Here it is, the area, how it looked like 6,000 years ago. You may notice that the ancient coastline, it is shown here, but nowadays we see it fossilized as beach rocks, as we saw in the previous slides. And as you may see from this map, there was a natural harbor that was joined with the sea through a narrow passage. So, based on the geological, sedimentological, archaeological, geomorphological, and biological indicators, the rate of relative sea level rise in central Cyclades has been reconstructed. Now, let's go to another area, Diolkos, the land road of ships. As you can see from these photos, it is obvious that the monument today is being destroyed by coastal erosion. In a recent paper of Vouzdoukas and his colleagues published in Nature, they mentioned that around 15% of the world's sandy beaches would face severe erosion by 2050, a number rising to almost 50% by the end of the century. A total 31% of the world's sandy beaches are in low elevation coastal zone, and their projections show that about 1/3 of these low elevation coastal zones will be seriously threatened by erosion by 2050. This estimate reaches 52% and 63% by the end of the century under RCP 4.5 and RCP 8.5 respectively. In these pictures, you may notice what is happening in many cases for protection and adaptation. You may see photos, the lowest left and right are coming from Egypt, but in the middle is coming from a Greek island, from Skiros. The upper two is the left from Italy and the right from Corinth Gulf in Greece. And this is what nature does. This photo is coming from the site in Naxos we discussed earlier. You may see clearly that the beach rock is a natural breakwater, a natural protection for thousands of years. And you may see here a wide and long sandy coastal zone in an area that normally receives an important wavy activity. Parallel to the coastal zone, you may see two series of beach rocks, and one more is existing even deeper. Based on the previous, we have tried to follow what nature is doing, and we create artificial beach rocks using local sand and local bacteria. And this is the sample opening after 2 weeks of experiment, and we have created an artificial beach rock, and it could be a solution for protecting the under-erosion threat cultural heritage without making the environment so artificial as we saw in the previous pictures in Corinth Gulf, in Skiros, and in Italy and in many other places all around the world, using so artificial ways for protecting, for adaptation and protection of coastal zone because of sea level rise. So thank you for your attention, and I remain at your disposal for any questions you may have.
We thank Professor Niki Evelpidou for her interesting presentation. Indeed, it is interesting to see how vulnerable we are towards climate change and how the changing sea levels can contribute and have contributed to the fall of many human settlements in the past. Now it is my pleasure to welcome to the floor Dr. Dimitris Sakellariou. Sorry for any pronunciation problems. He is a research director of structural marine geology and marine geoarchaeology in the Institute of Oceanography, Hellenic Center for Marine Research. We are pleased to have him here for a presentation named Cultural Heritage in a Dynamically Changing Natural Environment, Sea Level Changes and Geological Processes as Driving Mechanisms for the Drowning of Submerged Cultural Sites. Please, Professor.
Thank you very much. The floor is yours. In particular, thank you for the very good pronunciation of my name. And I'm grateful to the organizers of this very nice workshop for the very kind invitation. Well, after this very nice presentation by Niki Evelpidou on the changes of the sea level in the late Holocene, I invite you to join me in a more longer trip back in the time, in the last 500,000 years, in order to see how living, how active the Earth is in terms of geographic or paleogeographic configuration. So this picture shows how the Earth was looking like during the last glacial maximum. This is roughly 18 to 25,000 years before present, when the ice cover in the northern part of the Earth was extending in northern Europe, but mostly in North America. This was the most important ice sheet on the Earth at that time. Well, everybody is familiar with the term sea level changes and sea level fluctuation, not only the ones that are about to come, but the ones that happened in the past. So this is a nice curve of the last 500,000 years with a fluctuation of the sea level. The sea level fluctuates between two maxima. The high sea level is more or less what we see today. It's about 0. And the low sea level is roughly 120 meters below the present sea level. So the sea level fluctuates between those two maximas. But what are the parameters? What are the factors that drive this fluctuation of the sea level? There are three main parameters. The first one is eustasy, and this has a global impact. It is actually the transformation of water to ice or ice to water, depending on if we go from a glacial to interglacial period or vice versa. The second parameter is isostasy. Isostasy has an regional impact, and it is actually the response of the crust of the Earth when the ice sheet melts, so the crust unloads the weight and the response rebounds to go up. The third parameter, which has a local impact, is the tectonic movements. It's actually earthquakes. Talking about tectonic movements, we are talking about vertical or horizontal movements of crustal blocks, and this is why they are of local impact. A very good indicator to map previous sea level stands is to find the terraces that were formed during each of the sea level stands. This is a collection of pictures. The two on the left side are submarine terraces. The two on the right side are terrestrial terraces. All of them are marine terraces, The ones in the left are marine terraces formed at the former sea level, which are now submerged. They are submarine. The two on the right side are marine terraces. They used to form at the previous sea level stand, and now they have been uplifted. And they create this very nice staircase landscape. So we have terraces which have been submerged and terraces which have gone up. How is this possible? Let me show you two very simple animations which explain in a very simple way what happens when the sea level fluctuates and how the terraces are being formed. So we have an area, there is no tectonic activity, and there is only the fluctuation of the sea level between the high and the low sea stand. We have the formation of terraces, both at the high sea level and on the lower sea level, but always at the same time, because always the sea level comes back to where it was, either at the high stand or at the lower stand. Let's now move to an area with tectonic activity. So we introduce a fault on our nice landscape here, this brown line, and we play the same game again. So high sea level, we have the formation of the high sea level terrace, then the sea level goes down, but at the same time the fault moves, which means the left block goes up, the right block goes down, so we have this thing to be repeated constantly. The left part, as it goes up, then next terrace always is formed at the sea level, but the previous one is already uplifted. So we create with this nice game, this landscape, this staircase landscape that we see very many times in the terrestrial landscape, but also submerged. So are we in a tectonically active environment? Absolutely. Marsela was talking about the earthquake in Albania a little before. So this is a map of the broader area of the Aegean. With black lines, you see the active faults in the area. There are many, there are hundreds of them. And with red lines, you see the GPS vectors which show how the crust moves. And what we see is that the crust of the Aegean moves with something like 32 millimeter per year towards south-southwest. It extends, it stretches towards south-southwest. And this happens not continuously, but incrementally, with earthquakes, with fault movements. It would be interesting to keep in mind that a mean rate of vertical tectonic movements, which means along faults, it's roughly between 1 to 2 millimeter per year. If we consider that in the last 500,000 years, that means 500 to 1,000 meter of vertical movement, either uplift or subsidence. So, this is the present configuration, the geographic configuration, what we see today in the Aegean region. The numbers, the yellow numbers, show the Middle Pleistocene prehistoric sites where there have been remains of hominins of Middle Pleistocene age. And the numbers in red color are, again, prehistoric sites of Middle Pleistocene, which are now located on islands. And the simple question how prehistoric humans or hominins were moved to the islands. Let's go back now in time. In the beginning of Holocene, something like 11.5–6,000 years ago, sea level was roughly 60 meters lower than today. At that time, we see that the present shelf, or large areas of the present shelf, are exposed. Look at the Thermaikos Gulf, or the shelf in the North Aegean, where Thasos Island is. Many of the islands of the East Aegean were connected to the Anatolia, to Turkey, and some of the Ionian islands were also connected to Western Greece. If we go further back in time, so in the last glacial maximum, sea level was roughly 120 meters below the present sea level. What we see is that the entire shelf is exposed, so new areas, new, nice, fertile alluvial plains were available for the hominins of that time. All the islands of the East Aegean are connected to the Anatolia, to Turkey. Most of the Ionian Islands are connected to Western Greece. Crete, Carpathos, Rhodes remain islands. Even further back, we go in the previous high sea level stand. This is the famous 5E or 5.5. This is 125,000 years before present. A situation was more or less like it is today. Let's go further back. This is stage 6, another cold period, where we find the submarine, the terrace of that sea level stand at roughly 180 meters below the present one. You can see now the very big island in the area of Cyclades. You see extended land areas exposed above sea level. There are extended land bridges between Anatolia and mainland Greece, and those land bridges are separated by narrow sea straits, which might be able to be crossed by prehistoric hominids. So before that, we had again the interglacial, the warm period 7, 225 to 135,000 years before present, more or less like today, no interest. Let's move back. Stage 8, another cold period, where we find the terrace at roughly 280 meters below the present sea level. What we see is that we have really very extended land areas exposed. There are land bridges between the two block masses. Really great areas exposed to hominins. Crete and Carpathos still remain islands. Don't forget, we have Plakias and Gavdos, the two sites where prehistoric remains of more or less Middle Pleistocene age have been found. That means humans or hominins were there. The Ionian Islands are absolutely connected to the Western Greece landmass. So before this cold period 8, the warm period 9, again, more or less like what it is today, and we go to period 10, another cold period with the sea level to be found today at minus 380 meters. In this period, what we see is that the North Aegean Sea here has been transformed into a lake. There is no connection to the Mediterranean or to the South Aegean. Here again, there is a very extended land masses which make possible to cross or to walk from Anatolia to Greece by only crossing very narrow sea straits. Crete and Carpathos are islands. Period 11, another warm period, more or less as it is today, and we go back to 430 to 460,000 years, sea level at roughly minus 480 meters below the present one. There is a lake here, another lake here. Sea of Marmara was a lake. In the Central Aegean, there were many lakes. There was no connection to the South Aegean. The only connection was from the South Aegean to the Mediterranean through the straits between Crete and Antikythera, between Crete and Carpathos, and between Carpathos and Rhodes. Rhodes is already connected with Anatolia. Crete and Carpathos, even 500,000 years before present, retain their island character. Question, how prehistoric hominins reached Crete? They definitely crossed sea. So, I hope I have convinced you that Earth is a very living organism. It changes continuously, and I will show you only one small example of what is now hidden beneath the waves. As this very nice conference is also about nature, we had a very interesting survey in the northern Aegean, in the area of the Gulf of Strymon, between Chalkidiki Peninsula and Thasos Island. What we see on the map here are the seismic profiles that we conducted, and also the high-resolution bathymetry, as the colors which are more dark than the surrounding ones. And the reconstruction that we had, I forgot to say that this is the present-day Strimon River, and Nestos River comes here. This is the delta of Nestos River. So the reconstruction that we did with the data we collected showed that Strimon was flowing on the shelf of the Strimon Gulf and was outflowing there where the sea level during the last glacial maximum was at roughly 120 meters below the present sea level. Interestingly, Nestos River was coming toward this direction and was joining Strimon River. And then they outflow somewhere there. So if we focus now in the junction area between those two rivers, we see the following. So this is the high-resolution bathymetry of the area that we conducted there. You see a shallow platform here. It's roughly 60 meters deep today. And another flat area, which is at roughly 120 to 100 meters below the present sea level. That means we have a difference in altitude between this one and this area of roughly 40 to 60 meters. And we see these steep cliffs. So the cliffs are faults which have dropped down the left part of their side. Nestos River was flowing on this 60-meter deep platform. Strimon River was flowing at this 120-meter deep nice area, flat area. And the only way for the two rivers to connect to each other is to have waterfalls from Nestos flowing into the Strimon River. So at that time, in the last glacial maximum, 20,000 years before present, there must have been a spectacular waterfall in the area where Nestos was joining the river of Strimon. I picked up those two pictures. The upper one is a nice drawing of the waterfalls of Edessa. The lower one, I picked it from the website. I don't know from where it is. It may have looked like the landscape in the area of the junction of the two rivers 20,000 years ago. So there are spectacular things to be found beneath the waves on the seafloor, which is now drawn by the seawater. And what we do is we try to train the new generation of scientists so that they will be able to move across the boundaries between the archaeology and geoscience, and they will be able to understand the two disciplines, and they will be able to move forward and advance our knowledge. I'm grateful for the invitation, and thank you very much for your attention.
Thank you, Dr. Dimitris. It was indeed an astonishing trip in time, as you said. Now, after having a very nice group of presentations on that helped us develop knowledge on different aspects of the research done on risks due to human activity, development on climate change, we are, I think, ready to know more about policies in the field of environment and climate change. So I'm very pleased to give the floor to Mr. Panagiotis Tripontikas, who is Commander in the Hellenic Navy, Ministry of National Defense, Director of Military and Technological Support in the Department of Infrastructure and Environmental Protection. He is with us today online for having a presentation entitled Environmental, Energy and Climate Change Adaptation Policy of the Hellenic Ministry of National Defense and the Underwater Cultural Heritage, from where we are now to where we must get to. Please, Mr. Panagiotis, the floor is yours.
Thank you very much for having me here. I saw the presentations were quite very nice, very interesting, and I want to thank you because you are connecting the dots and connecting science with practitioners. So in the next 15 minutes, I will try to show you our policy regarding the environmental and climate change from where we are now to where we must get to. And let me start with a small video presentation. I will start with a quote of Georgios Seferis: "Erasing a piece from the past is like erasing a piece from the future," and I will try to give you the holistic approach of Hellenic Ministry of National Defense regarding nature and culture. So we are shaping our mindset on both cultural heritage and nature. And for us, it's not revolutionary, but it's the basic perception and cultural heritage and nature viewed as indivisible. So the contents of the presentation should be those that you can see the screen, but unfortunately, because time is constrained, I will go to specific the specific fields of interest and the underwater cultural heritage and the way ahead. Before we go on, I suggest you can to visit us to visit our website where you can see in the slide if you want to get additional information about our policy, where you can download also the policy. So, knowing that Hellenic Ministry of National Defense is an organization that can be affected by the environmental damage caused by third parties, we are an inevitable polluter in the context of completing our mission, and we are, of course, a support organization in case of emergency. And of course, we are one of the most effective international military formations and one of the largest state bodies at the national level. And because of that, we are required to act in a precautionary, administrative, and if necessary, restrictive manner on environmental and energy issues falling within its competence. So we have to implement sustainable development practices, and we are implementing. If we have operational requirements versus environmental protections principle, and if I had to ask you to answer me this question, a lot of people should say probably environmental protection principles, but operational requirements is the most important thing for us. But of course, any decision by the authorities of general staffs responsible for planning and conducting military operations must be duly substantiated. So the key pillars are shown in the presentation of our policy. We can give the most important pillar for us is the overall staff involvement, because without that we are not able to do anything. And the principles for our policy is prevention, precaution, proximity, in situ management, the polluter pays, and transparency. The means we are using in order to do our work effectively is those in the presentation, developing an internal regulatory framework. It's one of the most important issues, training, education, and personnel awareness, funding, and of course, establishment of cooperation. In Hellenic Ministry of National Defense, the management bodies is those that you can see in the screen. For ministry is my department. In general staffs and major formations is the Environmental Protection Department, and in formations and units is the Environmental Protection Office. Fields of interest for our policy, and I will focus on climate change, marine environment, nature and biodiversity, and cultural heritage. So you can see it in the slide. There is an interaction among those fields. So, oops, wrong. So climate is changing. The challenge is that the impacts are not always visible to us. That is the reason that everyone struggling to understand what is climate change and struggling to do actions for climate change. This is why we were struggling to understand. Life, of course, is full of struggle, but it is a struggle that creates champions. And for us, every challenge is an opportunity. Hellenic Ministry of National Defense is at the forefront of tackling this unprecedented threat. We saw in the previous presentations the impacts of climate change. So we have the raising of temperature in the surface water and of course in the air. The projections vary between 1.8 Celsius and 3.5 Celsius in average compared to the period between 1961 and 1990. Seawater acidification progresses, and I can show you what are some impacts, why climate change is a threat for our security. Let's see, for the anti-submarine warfare, the climate change implications is the increasing temperature that will warm the upper waters, and we have the increasing the speed of sound, we have salinity, and because of this, we have a change in transmission loss and detection levels. That means that we have a problem with weapons performance in torpedoes, and of course there is an issue on sustainability on climatological atlases. Here you can see a schematic summary for the possible impacts of climate change on aviation. Shifting wind patterns modify optimal flight routes and fuel consumption. Rising sea levels and storm surges threaten coastal airports. More extreme weather causes disruptions and delays and several other issues. But what about underwater heritage and the Second World War naval vessels? Most of these ships are made of rusting metals, still hold armaments, vast quantities of oil, etc. So the climate change implications, temperature, salinity, and acidification. So we have a change in chemical changes. The seawater becomes hotter and more acidic, and shipwrecks are deteriorating. We have a possible loss of cultural heritage and environmental, of course, disaster. Regarding nature and biodiversity, we are adjusting everyday activities, planning and executing exercises in order not to affect protected areas and to limit possible pressures on the natural environment. We know that protected species are not limited to the protected areas boundaries and can cover long distances searching for food. That's why we are always aware of the increased risk of frequent accidental encounters and disturbances outside their boundaries protected areas. We can see here a map with the protected areas and the important marine mammal areas, and we took the initiative in order to project all these areas in the nautical charts and in every product of hydrographic service and geographical service of the armies, in order to give the scientific information to the practitioners. The practitioners are the people that they are traveling with boats. They are using one tool, and it is the nautical chart. So this is our first nautical chart. You can see the island of Agios Efstratios and the marine protected area over there. We also work together with HEMR, and we had to put also the Posidonia beds in the map, requesting kindly to the people to avoid anchorage over there. Here you can see in a better view. So all the protected areas are going to projected in our nautical charts. Here you can see the area and the Posidonia beds. Regarding the marine environmental activities related to the use of warships, submarines and aircraft to the armed forces carried out in a way that causes the least possible damage to the marine environment. For example, no activity involving air launch of live or inert munitions is to take place inside or within 500 yards of the marine protected areas. All low-flying operations are avoided. Fast-inch or attacked craft, when operating inside these MPAs, we are always we keep a moderate speed and proceed in such a manner in order to eliminate risk of unnecessary disturbance. Anchoring is never taking place in or within 0.5 nautical miles of the marine protected areas and Posidonia beds. Our submarines record marine mammal sounds, recognize biodiversity and perceive marine life more directly than anyone. All units, of course, should identify where Greek Natura 2000 network is located and quickly understand what is appropriate and additional precautions may be necessary to safeguard these legally protected sites while maintaining the freedom of maneuver within and in the vicinity of these sites. Regarding the underwater cultural heritage of Hellenic Ministry of National Defense, this is a property of shareholdings Navy funds. Some of our historical wrecks are war graves, are habitats for marine life, contain dangerous cargoes of live munitions. Of course, all have an important history to tell and hold clues. So we say to everyone, don't damage or disturb them, don't recover any object, and report, of course, your discovery. Coming now from where we are now, preserving the historical and cultural environment, we are going to a strategic approach from the era of research and innovation by creating the repository of cultural heritage of Hellenic armed forces. In order to secure the integrity of locations with historical and cultural heritage from military activity, we are promoting after proper recording, restoration and maintenance the means, buildings and areas of historical and cultural importance. We encourage cooperation with and within the state and scientific bodies as well as with local authorities. We understand the need to inform all interested parties about all. Time is running out. All interested parties about all areas of historical and cultural importance, even in peacetime, is justified in order to ensure that military operations can be carried out with the least possible damage to the environment. Our top priority is to map the areas of historical and cultural importance in all printed and electronic products. As we saw before, here you can see another map of Leros Island, where you can see the historical wreck. This is before the map, and we know that the nautical charts and in general the charts, these products are unique tools that connect people with our natural and cultural heritage. Our goal is to create our standards and guidelines that will give answers to the basic questions who, what, where, when, how, and why. Creating the handbook for recording historic wrecks. Creating, of course, the important baseline information. The guidelines for public access. I'm not going to move now because I don't have the time to give you further information about that. Of course, the most important thing is the risk assessment and connected with the permission system, standard process for the identification and management of risk associated with the permission system. A historic wreck site presents an unacceptable risk to human safety, is extremely fragile and in danger of collapsing, and of course is suffering extensive deterioration or attrition due to prior unregulated access. In general, a decision has to be made to limit, monitor, or prohibit access to a particular historic wreck following marking restrictions in notice to marriage. There is a work to do, considering how to maximize access while maintaining personal safety and site security. We are working tirelessly to expand our partnerships, and thank you very much for the invitation once again. There is a need of joint effort, co-perception, cooperation, and communication and public outreach. In order to have a common goal, protection and promotion of natural and cultural heritage. Of course, we are running out of time. We believe in synergies, and at the end, if synergies are promoted, of course, conflicts are avoided. We are preparing now the roadmap to climate change adaptation, because we believe that the more climate prepared defense is, the strongest Greece will be. That's why we have a program in progress. This is a Monuments at Risk initiative. I'm not able to give you any further information, but you will have it soon. We are working together with the Ministry of Culture and Sports. So ending this presentation, thank you very much for having me here. Stay safe, stay tuned, and we will very happy to meet you live and to work together towards our common goal for to protect our cultural and natural environment. Thank you very much.
Thank you, Commander. And congratulations for the anniversary, 200 years of your institution. I was very impressed to see the long legacy of the environmental protection in the Ministry of National Defense in Greece. Klodjana?
Thank you, Mr. Tripontikas. And also from me, congratulations for your initiative for standards and guidelines. Now, last but not least, I'm pleased to welcome Dr. Paraskevi-Nomiko for taking us to a virtual diving experience in Santorini. Created by a team of 50 members, it shall be presented by Professor Nomiko from Department of Geology and Geoenvironment, National and Kapodistrian University of Athens. The floor is yours. Thank you.
Thanks a lot. Thanks a lot for the invitation. So let's stay at sea, okay? Because all the previous presentations were at sea. So we have seen very nice nautical charts. So let's go back to the South Aegean Sea, and we will virtually visit Santorini volcano. And unfortunately, we don't have the Oculus with us just to explore what we have already found on this island. But at the end of this presentation, I'm going to show you a short video just to have an idea if you wear the Oculus and dive with us in the very nice underwater environment of Santorini. So I'm going to speak about the virtual diving experience in Santorini. It's a PANEC project together with Tetragon, Aptometric, Steficon, 3 companies, and of course the National and Kapodistria University of Athens. So most of the times, if we want to explore the underwater environment, what we are going to use? We're going to use ROVs and submersibles, and if we want to map the seafloor, we need to have AUVs in order to map the seafloor in very detail. Okay, so any kind of this type of environment is very unusual for the common people. So we create a very nice project, a very digital platform, in order to give the opportunity to the ordinary people to visit the underwater world and, of course, to explore the experience that we have if you are an oceanographer. So this is the virtual diver. Just a very short, what is the scopus of the virtual diver? First is the development of innovative product of the provision of specialized services in tourism and of course also in education. Okay, so to promote the cultural heritage of Santorini as a case study, but we may also use the digital platform to all the other areas in Greece. The combination of research results, because we have already explored the underwater environment of Santorini and we have done lots of researches in the underwater environment and also onshore. So we combine all this type of results. Of course, the creation, as I told before, a complex digital platform for the realization of visual experience and of course augmented reality experiences. And of course, this is very well, I'm going to show you some 3D models. The development of mapping methodology and 3D visualization of the underwater area and of course the onshore area of Santorini. So this is just in general, this is the system of the digital platform. As you can see also on the screen, we may use various types of multimedia, 3D video, panoramic views, some interviews of the experts like a geologist, a diver, an archaeologist, an architecture. And of course, we have interactive technologies, tools and practices, virtual reality, augmented reality, and of course, multimedia. And of course, we combined onshore and offshore data in a virtual environment. Okay, this is the system highlights and disciplinary design process. So the platform is based on collaborative relationship of experts, because in the team we are different types of people that we are working in Santorini. Like we have geologists, but we have also architectures, or we have people from the computer science. Of course, the design of the VR dry dive experience is the virtual diver is a custom-made at-end environment within the Unity environment. It's a very, very friendly environment in order to use the Oculus. And of course, at last, this is the interacting and navigating in VR environment. So it integrates a set of available technological tools and methodologies in order to provide the cultural heritage of Santorini. Okay, so as I said before, we managed to combine and create 3D terrains, and we may fly above Santorini, and of course walk and of course dive. This is very important in a 3D reconstruction of this very nice and very unique volcano of Greece. And except of the 3D reconstruction of the whole landscape of Santorini, we have also created narrative scenarios. So if you wear the Oculus, you have the option that you are in Santorini, and also you can hear the experts following a specific scenario. On this slide, as I said, we have a detailed, you may use a detailed and visually accurate mapping. In this screen, you may see the underwater geological map of Santorini caldera. Each color represents different underwater geological formation. And if you dive there, I will show you on the video at the end, you may explore and you can even touch the geological formation of caldera of Santorini. Of course. So you may explore the area of Santorini. Santorini is it's a stratovolcano, and of course the caldera is very unique. It's one of the biggest caldera of the world, with a dimension of almost 11 kilometers north to south. But if you want to drain the ocean, okay, so you may dive and you may explore the area of the underwater environment, and each pixel gives you an opportunity to dive and also to make known the underwater environment and the geological formations. For example, this is the sediments of the northern part of Santorini caldera, and if you go very close to the slopes, you can see even the landslides, okay, of the volcano. And as I said before, let's hope that they will play, okay? So you may fly very close to Ia. So we have created 3D environments using the drone images. Also, you may dive very close to the slope. So we use ROV photos, and we created photo mosaic and 3D models of the underwater seafloor of Santorini. So we try to combine onshore, as I said before, in Ia, for example, the village of Ia, and also offshore data sets. Okay, so let's be focused for the underwater data sets. We used Okay, so we use ROVs, portable ROVs, in order to collect videos and photos, okay? And we collect the data carefully, designed, fully plans were designed in order to capture the areas of interest with almost an overlap of 80%. For example, on this screen, you can see some lava dikes, vertical lava dikes, and we wanted to explore what is happening on the seafloor, or if all these lava dikes continue very close to the seafloor. And of course, we have very interesting photos of this area. And of course, we have mapped this area and we created photo mosaic of some shipwrecks or the underwater geological formations. And we follow all the scopus and, of course, the methodology in order to create the photo mosaic. We didn't only collect the photos and just put it in the software and create the 3D model. But, for example, we evaluate a camera model. And of course, we know that all these underwater images, they create some greenish and bluish effect. They have haze effect, low contrast, noise, or lack of vividness. So we follow the methodology. All the colleagues from Virtual Diver, and especially the colleagues from Optometric, they follow, for example, they did the saturation encasement, Rayleigh distribution adaptation, haze reduction, global image equalization, image sharpening, in order to produce this kind of underwater images. For example, this is an image of a shipwreck at Amoudi Bay at the northern part of Santorini caldera, or 3D models of the environment. And as I said before, you may see also some pictures, some photo mosaic from the lava dikes. This is a lava dike. This is a vertical lava dike on the seafloor. Okay, and we saw the continuation of the lava dikes on shore of Santorini. And also this is the shipwreck of Santorini, very close to Amoudi Bay. Okay, except of this photo mosaic, the 3D models, and all of these impressive photo mosaic schemes, in the digital platform, we may use some other interaction components and methods. For example, we use image component, we use gallery component, panorama component, 360 degrees component, or video, or many other components that you may explore of Santorini caldera. This is a small slide from the Unity Editor image viewer interaction component. What we want to say for this, that this environment is very, very friendly for the people that are not familiar for the computer science. So you may create your digital platform, just upload your data on this digital environment. Okay, so in the platform, we have image viewer component, many images that they may explain what is happening in Santorini in some areas, for example, or we have 360 degrees object viewer. I'm going to show you a small video. And of course, the design principle. So we follow the presentation of content in various media. For example, you may use this platform wearing the Oculus or in your tablet. And of course, everything is very friendly. So everything is being explained very, very normally without using very difficult geological explanation or architectural explanation. Of course, this is one slide of the platform. Give me some photos of Santorini. This is the slideshow component. Or, for example, this is a geological rock of Santorini. And on this video, okay, let's play. Okay, so you collect a rock. Okay, the rock is rolling it down, and also you may have some information about this Georgios lava fragment of Nea Kameni, for example. As I said before, you may explore Santorini using the guidance of some experts, like, for example, geologists or divers or architects or historians, and also you may hear the story of Santorini volcano. Okay, the interaction components and methods, so considering the end users' needs and requirements, a set of UI designs was implemented based on best practices for VR user interface design, combined with academic research specialized in VR application development, in order not to have some problems if you wear, for example, the Oculus for many seconds or minutes to feel dizzy and so on. And of course, just in front of you, I will show you the video at the end. You have the interaction components controller in order you may choose what you want to see. Okay, or you may also have a map and you may choose your route, okay, and explore, for example, the northern part of Santorini caldera, and all these points have something to show you, like a cave house or a castle or a geological formation, for example. And of course, for example, if you click on that, you may see some information about Ia, the village at the northern part of Caldera. And as I said before, you may fly. Okay, so you have the fly mode. You may walk. For example, you may walk around Georgios crater in Nea Kameni, and you may have an expert that can say to you the geological history of Nea Kameni. Or, of course, the most impressive one, you may dive in Santorini caldera. For example, let's play this video. You may dive around Nea Kameni. This is exactly what is happening on the seafloor. So you have the opportunity to dive with me at the depth of almost 300 meters and explore the geological formation of Nea Kameni. Or, for example, you may click on some points and see, for example, photos of the sea environment of Santorini caldera. Or also, you may choose some other routes, okay, and go to the other place and see the shipwreck on the seafloor, and also the history of this shipwreck and what is happening. Okay, so click on that and you have the Santorini shipwreck story. And of course, and I'm very proud of this, we have finished the representation of Santorini volcano with the help of Tim Druid, the famous volcanologist. He is the person that has created the geological map of Santorini. And I will show you a very small video how Santorini looked like before 600,000 years before. For example, we had only 2 small islands. And this is the 3D animation show us, very impressive, and we are very happy on that, how Santorini has been created and have at the end the last hymn that we present today. Okay, so this is a very short video. The original video lasted for about 9 minutes, and we have many informations about this. And of course, I don't think that I'm going to read all of that because I know that we don't have lots of time. Okay, so this is a virtual platform, for example, in order to promote the cultural heritage and especially the underwater environment. The case study was in Santorini, but as I said before, we may use this platform in other places. And before I'm going to thank you, I will give you the opportunity just to wear the Oculus with me, okay, not in reality, in real time, but having the chance to see the promo video that we created as a team. Okay, so can we play the video, please? Okay. Okay, thanks. Okay, so just imagine that you have already wear the Oculus and you now fly and you are just at the northern part of Santorini and you click on Ia, okay. And then if you click in Ia, you may choose also some other parts of Santorini, but just click on Ia. Okay, so now you are in the square of Ia. And you may choose in the components, for example, what is Ia, a small text. Or also you may choose some photos or some interesting parts about Ia, for example, the naval history, or some photos, as I said before. You may play on that. And also, you may go to another place. For example, this is the central square of Ia, but also you can go to the panorama place. You may also visit a place that you can see, that you can have a panoramic view of Santorini, like here. And also in this place, we use 360 videos, okay? So you can make around. Now you are wearing an Oculus, okay? Unfortunately, we don't have the Oculus here. That's why we create this video. And also, you have exactly the same components. So you may see the photos, some photos of the area. This is the 360 photo, of course. This is Santorini caldera, the northern part. And also you may fly. Okay, so for example, you may visit the northern part of Santorini caldera, and you may choose to go to the place that most of the people want to go, the place that you may admire the sunset of Santorini, in Ia. Like here, very close to the castle. Okay. So this is the most famous place in Santorini, so most of the tourists, they are going there in order to admire the sunset, but still you have the same components, okay? So still you can see the photos, or you can have a 360 video, or also you can have an expert to explain to you about the history, for example, for the village of Fia. Okay, so this is the famous castle of Santorini. This is the castle of Fia, or you may go and walk within a cave. So most of the houses of Santorini, they have name as Hyposkafa, is the cave houses. So you may walk within the cave, okay, and you may explore what is happening there, and also you can have an architecture to tell you about the history of the cave houses and the architecture of the houses in Santorini. This is also very impressive because you have the feeling that you are within the cave house, that you are inside. Okay, so you can play around, and also you have exactly the same components. Also, then you may choose to go out of the house, for example, to go again to the panoramic view. And okay, and this, I think this is the most impressive one because you are walking in the narrow streets of Fia. So you have the feeling that you are there, even though you didn't have the chance to visit Santorini. With a digital platform, we have the ability to walk in the very narrow streets of Fia and also to admire and also to see the view of this magnificent village of Fia. So you can see this is the 3D reconstruction also of the village of Fia. I think this is more than reality, that you can walk, okay? You have the ability to walk, and of course, you may choose the experts to have a story, or you may choose some other route to go from one place to another place, okay? And let's go and dive, I think, yes, let's go and dive from here, okay, and see what is happening on the seafloor, just to explore the geological formation in Amoudi Bay. Okay, so you may go around to see what is happening and also to choose different signs. You may choose, for example, this sign, and this is a shipwreck. You have the story also, as I said before, of the shipwreck. To tell you the truth, it's very impressive. If you are wearing the Oculus, I cannot express my feeling when I wear the Oculus and I say, wow, so now I am on the sea environment, okay? So I'm diving within Santorini caldera. And you can go around, and of course, all these rocks are real. You feel that, you have the feeling that all these rocks are real. So you have the ability to explore. And of course, the same components, you may use some videos, some photos of underwater environment. And of course, there are some other signs. We couldn't have the chance to show everything on this video from the digital platform. For example, this is a video, okay? As you can see, the environment of Santorini. And of course, you may also have an expert, like a diver, to explore and say what is happening on the seafloor and how we map the seafloor, or how we may use the ROVs and AUVs. So you have the chance, if you have the ability to explore the Santorini from this digital platform, I think this is the end, okay, to have the chance to be in Santorini, to have a very nice taste of Santorini without being there. So thank you so much for your invitation. Thanks a lot.
Thank you, Professor Nomiko, for the unique experience and for this excellent conclusion of this session. Thank you very much. Indeed, it was, in my opinion, a unique experience for all ages of virtually walking and flying and diving in a splendid environment. I wonder if it has plans for being replicated in other sites also?
We have plans, yes. We have this application in other places. Like, for example, in Niceros, it's another volcano. We try to use this kind of digital platforms in other places that they have very nice geomorphology, okay, onshore and offshore. And of course, to promote the cultural heritage. If you have a castle, for example, underwater or also very close to the shore, you may use this type of digital platforms to show them to the audience. Okay, I think this is a very unique experience.
Yes, yes, indeed. Thank you very much for your intervention. We are very pleased to have concluded the presentations for this session. We shall enable some space for the discussion and any question that either the participants, the speakers, or the audience from online audience may have. I am indeed very pleased, and I think also Klodjana is very pleased to have been part of this session with a very nice bouquet of presentations that were each of them presenting a different aspect of research in types of risks for climate change in the cultural heritage and natural sites. We had the possibility of having both aspects of nature and culture in the presentations, and I want again to mention one sentence of Mr. Panagiotis Tripontikas. We were able to see how science was connected with the practitioners during the different presentations. I want to give the possibility if any of the participants, speakers, has any observations or comments or questions. May we see the online participants if they are? Hello. So maybe I can start with a question for Professor Belisa. I would like, I wonder if she can say us a little bit more of any plans, any possible plans that the digital technologies that she mentioned that plan to be used in the research for seeing the transformations and meanings of the transformations on the open archaeological sites, if there are any plans to integrate them in the education programs, considering that the Institute of Archaeology is also one of the main academic institutions in the field of archaeology.
Thank you very much. Thank you very much for such a nice organization, first of all, and then for giving me the possibility to express some of the results of a job that is done by a team. So the results of what I presented today actually reflect long years of work and experience in the field. Yes, your question is a very nice one, and of course, in my belief, is a necessity. If our research is not touchable or accessible, culturally speaking, or in terms of communities, then there is something wrong in the meta. So there are several levels of integrating our results within the cultural, let's say, programs. First of all, there are the publications, but of course, you know, they interest a smaller group of people, so it's a very restricted area there. And then there are our collaborations with the local institutions and structures operating in each site. So we try to work together so that we can share the results, and they are the first people to integrate the new results of our research within their itineraries, their contacts with tourists and everything. And then, of course, there is the university. So there is another level of introducing our results every time, whenever there is the possibility, as we are, of course, part also of the education system within the university system. And then, of course, there was a very good experience with the archaeological park of Apollonia last year, with a project financed by the Ministry of Culture, which saw, of course, the creation of the first ever maquette of the Apollonia city in the antiquity. Of course, it does not reflect every phase. It reflects the biggest Apollonia, the moment of its peak, let's say, of its hugest form of organization and, of course, territorial expansion of the city. But it was a very good exercise, and it was a very good result, because now we see, and I did have the chance to process with the director of the park, we see that people tend to even to enter the museum more because they need to see the maquette by themselves. So they have a grasp of what the city represents in its most important phase. Something similar is about to happen in Phoenica. Again, there is something that has been supported by us, but of course, financially speaking, by the Ministry of Culture, to have another form of interactive map of the structures with a small history, and then with these changes, with this, let's say, new results that are now available, that can be integrated. But of course, some things tend to change, need some time to change. So if we have considered, for instance, the theater, the so-called theater of Orikos, for decades, it's quite difficult to make a change within a couple of years. So, but they will come. Now we know that people, the ones that are interested, of course, that are sensible to archaeology, they see the difference, and of course they embrace it. And then of course there is the dissimulation of the results by the means of media, different forms, interviews and everything. So I think we are approaching the situation, the problem, the issue to the right directions. Thank you.
Thank you.
If there is any question on the second presentation on rapid damage assessment of the earthquake of Albania. Okay, we can continue with the third presentation of Mr. Renald Meta, risks and benefits of cultural heritage from construction project. Okay, we can continue if there is any question for the CLIMASCAPE project. Okay, in fact, I have a question for the last presentation, the wonderful virtual tour in Santorini. Professor Nomiko, I was wondering how much time it was needed for preparing all this project. You can have
I think this is a very good question. Okay, so the duration of the project was 3 years. So we are almost at the end of this project. But I think in order to collect the data, you need approximately 1.5 years. And due to the fact that you need to collect also data from the seafloor, and this is very expensive sport, just in general, but it's very also not so much, it's very ambitious, and you need also to take account the weather conditions, so you have lots of difficulties. I think you need almost 2 years to collect the data, and of course 1 year in order to create the digital platform. But the first step is to have the data. And then if you have the data, it's very easy to create the digital platform and also to have all these 3D photomosaic and 3D photomosaics of the whole structure of Santorini. Okay, so approximately, let's say 2 years for sure, in another area. If you need to plan to have the digital platform in another area, let's say for 2 years, that's for sure. Okay, so that was a very good question, yes. Thank you so much.
I found also interesting the interviews. Okay, Marsela.
I would like to ask Mr. Panagiotis, Tripontikas. He mentioned in his presentation that if is Mr. Panagiotis online? Okay.
Yes,
Yes.
I'm here.
You mentioned in
I'm
your...
not able to see. Yeah. Anyway.
Okay.
Yes.
I was wondering, you mentioned in your presentation the establishment of collaboration as one of the pillars of your work, and the agreements with government, other governmental bodies responsible for culture heritage, such as Ministry of Culture, etc. I wanted to ask, in case, how you proceed for collaborations with private entities, businesses, or even inhabitants, persons, community that may have activities in the marine environment. How you integrate the work, or you proceed in such cases?
Okay, thank you very much for the question. In general, we are working to create such collaborations, okay? But these collaborations need to have a memorandum of understanding. Without a memorandum of understanding, it's not possible to have a creative work together. For us, the common goal is the cooperation in order to both to be beneficial for each of the parties. Okay, so we need the scientists to work together with us in order to have a common view about the prospects of the works they are doing. For me, the most important thing is for us to understand the work that has been done in the recent years, and of course the work that needs to be done in the upcoming years. We have a very difficult threat to deal, which is climate change, and without strong collaborations, we are not able to deal with this threat. I mean, together we can achieve the most wonderful things. Each one alone, I think that is working without to be resulting, to be, it's not very good. So we are working, we are waiting, we are having also collaborations together, for example, with HEMR. We are working together with Posidonia beds to put all the Posidonia beds in the nautical charts, and because we are working together, we can understand what is Posidonia and why it's so important for community, in order to pass this information to our crews, to our soldiers, to everyone, because this is the most difficult part, to have a common view of the treasure we have in Greece and in general the Mediterranean, because we all know that Greece is a hot spot of biodiversity and culture.
Yes, thank you.
You're welcome.
So, in case there are no further comments, I believe we successfully closed the third session of the Mo.Na conference. I would like to thank the European Center for Byzantine and Post-Byzantine Monuments for the whole organization of the conference, and welcome you tomorrow for the fourth session starting in 9:30 a.m. Thank you very much. Good afternoon.